So we have to find out reaction force at A. A and B. We can see A is a pin support, which means it will provide AX and AY in both X1 and Y direction. And B is a roller, so which means we only had BY. So how we are going to solve reaction forces here is we are going to take the whole beam as our FBD. So for this FBD here, you have to include all the forces, the reaction force. We have to calculate all the external forces. We can see we had a moment at 2 meters, and then we had 8 kilonewton going this way. And since we are taking the whole beam as our FBD, so which means we can try to simplify the distributed load. So the total force will be the area of the load diagram. So it will be 15 by 345 kilonewton. So once we include all the forces, the next thing you have to do is try to mark all the dimensions so that you will be ready to write down all the equilibrium equations. So we can see the moment is acting 2 meters away from A point, and 8 kilonewton is a little bit further, and the dimension for the BY. So now what we have to do is try to mark where is the simplified the total force for the uniformly distributed load. This is a triangle distributed load, which means it will pass through the centroid, so which will be 1.5 meters from the B. So after you include all the forces, all the dimension, which means you are ready to write down the equilibrium equations. So most of the time what we are going to do is trying to summarize moment around most unknown forces, so which will be the A point for our case, and counterclockwise moment will be positive. So now let's summarize. So we had 20 kilonewton, but clockwise negative. And then we can see for the 8 kilonewton here, it will create a moment. It's a clockwise moment, so we put a negative sign. So force times the distance. So the distance from 8 kilonewton to A point will be 3 meters. And then we just keep moving. We had a BY multiply the total length. That's going to be 5. And then we still had simplified uniformly distributed load. 45, multiply the length to the A, which will be 5 plus 1.5. So once you done every load, everything summarized to the 0 in this equation, you can see we had one unknown force, so which means we can find the BY is equals to 7.3 kilonewton, and it's positive, which means our assumption go up is correct. So after you find the BY, which means if we summarize the force in the Y direction, we should be able to find out what is AY. And we can also try to summarize the force in the X direction so that we can find out what is the AY. So for our case, there's no horizontal load, so which means AX will be 0.